So again, the drill is pass them up to the front, then over here to the first seat, and then he puts it on my desk. Remember not to turn in work in the baskets. What goes in the baskets? Already graded work waiting to be returned to you. If you're absent or you're allowed extra time, you need to get your head up. Or you're allowed extra time, you're going to turn that work in where? Me directly, or on my desk. Don't put it over there. If some of you follow directions, some did not. If you follow directions, there's nothing on your desk but a pen or pencil right now. Remember too that you're checking your desk for any marks when you come in. If there are marks, you tell me, so if I see them at the end, I'll know that they didn't come from you and I won't hold you responsible. Okay? All right. The point of this exercise was to give you the skills of evaluating a web page. How many of you do research this way? Teacher gives you a topic to research. You go home, you go to Google, and you type in those words, and you look at what comes up on Google. Okay. Google's a pretty popular website, right? Pretty popular search engine. Do you know how they determine which one is number 1 on Google, 2, 3, 4? You know how they're ranked? Sort of. Popularity. It is a big popularity contest. Okay? Is that a good way to determine if something is reliable? Popularity. Ever heard of the magazine or newspaper National Enquirer? Woman in Kansas gives birth to alien baby with 3 heads. Ever seen some of the titles, headlines on those? Okay. Yeah. Now, is that a popular newspaper or magazine? Yes. Very popular. They sell lots of copies, lots of people read that stuff and believe it. Because something's popular, does that make it trustworthy, reliable? No. And yet we read these things and we start to accept them. And a lot of people mistakenly think that anything that's on the internet is real, is true. And there's a lot of garbage out there. No one's filtering this. And so you go on and you type into Google one of these words or things that you're researching, and you often go to the first response, right? You got the list 1 through 10 or whatever, and you click on the first one. Well, last year, that's how I did this assignment. I had students research dihydrogen monoxide and the tree octopus using Google. And if you were to click, use Google, and you were to click on the first response for each of those, you would get these 2 websites. I didn't do that this year because the first hit, if you will, on Google for the tree octopus, that website's not working. So I found it someplace else and I linked to it. That's why I set it up this way. Okay? But so many of you trust those first responses. You think it's reliable information. So that means that you have to be smarter than the person using, the person that set up the web page. They're going to try to trick and fool you. This particular website, dihydrogen monoxide, was set up, or the idea was set up by a 7th grader, a long time ago, as a science project. And now we use it, teachers use it, to show just how gullible, how easily fooled people are. Not just 7th graders, 8th graders, and grown adults. But there are a lot of clues on this page, on this website, that this is bogus. You know what they are?
Well, like, I was looking at all the facts and you said it boiled, but you said that kind of water and boiled and that the water coming out of the
Well, see, now that was smart. You took the extra step. Now, Google may have misled you, or in this case, it might have helped you out. There's a lot of facts on there that are accurate. Dihydrogen monoxide is a dangerous substance. It has caused many, many deaths. People get too much of it in their body, they die. It has been known to cause car accidents. It damages homes. Hundreds, thousands of homes every year are damaged by dihydrogen monoxide. Okay? Causes all these deaths. And so this 7th grade girl, it's her science project, she presented this to her class and told them all the problems with dihydrogen monoxide, how it can kill you. And then passed around a petition. I'm sure you guys have done this at some point in school. You're mad at somebody or something, and maybe your teacher, and they passed around a petition, and you're like, oh yeah, I'm going to sign my name. You look at who else signs their name, you just jump on the bandwagon. I'm going to sign my name too. You just take the stuff off your desk. Thank you. Well, she got most of her class to sign a petition to ban dihydrogen monoxide. That's basically saying, I want to die. You're signing your own death warrant. Because if there's no more dihydrogen monoxide, you are going to be dead. DI is a prefix that means the same thing as BI. BI, as in bicycle, means two. Di means two. H stands for hydrogen. So you have two hydrogen atoms. Mono means one. Oxide, or the O, stands for oxygen. So you have two hydrogens and one oxygen. What are we talking about? Water. That's just another name, head up please, another name for water, dihydrogen monoxide. Head up please. So what she was trying to get her 7th grade students to do is to ban all water. Does water cause car accidents? Slippery roads. Does water damage many homes? Floods. Does water kill people if too much of it is taken in your body? Yes, we call that drowning. So all the statements were true, but you don't have the full picture. This is not a real thing. Well, it's a real thing. There really is dihydrogen monoxide, but all the fears and dangers are misleading. Okay? What were some clues that this was, besides the research you did outside this page? On this page, were there any clues that led you to believe that this was not what it seemed to be? Did anyone pick up on any clues?
Yeah, because there's a saying that it's seen it like a high school shooting and used as a performance and
Yeah, if you want to do well in sporting events, you need to have enough water. You picked up on the boiling and freezing point. I didn't even realize that was on there. Somebody pointed out about fake email spam thing over here. You know, they put other things on here to make it look legitimate. There is a store. You can go and buy banned dihydrogen monoxide shirts. Okay? Well, the same thing could be said for the other site. This one here, the Tree Octopus. They have a store that sells t-shirts and buttons. Save the Tree Octopus. Okay? They talk about the Tree Octopus, they give all this scientific information. Later, they tell you about how they used to be used as hats, and that's why they're in such small numbers nowadays, because they were so popular back in the 20s. And it all looks very legitimate. They may even name scientists and experts and have special organizations. One of the clues that this is not what it seems to be is the address itself. This is a school website. It happens to be a school website, but some other teacher is using it to teach students that you look at the website carefully before you decide if it's real or not. It's not a special organization to say that. It's a school website. And I could go on the school website and make a bogus page saying how I'm the leading expert in alien research and make it sound all official. You need to check those references. Who is this Mr. Myers, this Dr. Myers? Where did he say he went to school? Harvard? Okay, well let's go check that out. What did he get his PhD in? Was it astronomy? Was it geology? Did it have anything to do with what they're talking about? Because if we just read and believe whatever's written, you're going to be a sucker. Just like all those 7th graders were. Okay? Farther down the page here, there's a big clue. Anyone pick up on that one? What was it? Yeah, I think you're going to say it. Right here in the middle. Talking about the tree octopus's habitat. Lives in those trees in the rainforest. Its main predator is Sasquatch. You got it. The bald eagle and Sasquatch. Okay, that should ding, ding, ding. All sorts of warning lights should come on for that one. Okay. Lots of things to make it look legitimate, but it only takes a few little clues to lead you to believe. A few little clues to lead you to believe that this is totally bogus. And that's what I wanted you to learn from the exercise. Don't believe everything you read on the internet. There are certain tricks that you can use. I named some already. Who wrote this? If it doesn't put the person's name up there, be suspicious. They should be given credit for what they wrote. And who is that person? Do they have training in that area? Are they an expert? Where's the website coming from? Is that a trustworthy place? You know, Harvard.com or Harvard.org might be a little more trustworthy than JoeBlow.com, you know, that just made up his own website, and he's not an expert in that area. Get it? Okay. All right. I need to cover a few more things on our rules and routine, and then we'll get into the rest of today's lesson. When you come in, if you need to sharpen your pencil, there, do that first. Come prepared. If you have extra time to kill, which is rarely the case, you can come over here. I don't do bell work, because we start right at the bell. But you can explore stuff over here at the Science Explorer Center, or Explore Science Center. These are all little demos like you have in a science museum. Feel free to use them. Read the directions. It helps you to get the effect, okay? But then put them back when you're done. These are all my own personal things, so please treat them with care and put them back where you got them. At some point in the year, I'll offer some extra credit based on what you can learn from using these. So if you have the time, do that. Just make sure your butt is in plastic when the bell rings so you're not target. Head up, please. Okay? A lot of you with gum, you need to stop doing that. I want you to spit out the gum. Okay? Some places you don't go. When you come in, this whole zone, all of this, behind the table, all the way over to this door, is off limits. This is the no-fly zone. Unless I have you come up here to write on the board, you should not be back here. And you should not be grabbing anything off of this table or my desk unless I told you specifically to do that. Obviously, don't go back in there. When you're at the lab station, station 8, 7, 6, 5, 4, 3, 2, 1. When you're at the lab stations, you are not to be opening the cabinets, messing with the cabinets. They're usually locked anyway. You're not to be messing with the gas and air valves. Okay? They're usually turned off anyway, but you can leave those alone. If you do, that's a good way to get kicked off the lab. Let's see. If I catch my hair on fire, first thing you do is point. Second thing you do is laugh. The third thing you do is go to the back of the room and get the fire extinguisher and put my hair out. Up here is the chemical shower. This is to spray you with water or rinse your eyes out if you get chemicals on or in you. We're not going to be dealing with any chemicals that will present a problem, so that's to be left alone. Let's see what else. Fire drill. If we have a fire drill, you leave all your books here to burn. We get in a single file line and we head out that back door up the hill. Obviously, we can't do that right now because there's a big fence across there. So we would be going out this door for the time being and probably meeting out front on a single file line. Okay. Anything else? I have a daily riddle. I forgot to tell you the class is this. I have a daily riddle or question on the board. Usually it's a lot more interesting than that. That's just an example. So you can always sit down and ponder that as well. Head up, please. And I think that's it. My objectives, what we're doing, are always written over here. If it's in black, it's usually me talking. If it's in blue, it's something that you're going to do, usually in class. And if it's in red, it's homework. Because this is blue, underlined in red, what does that mean? Started in class and finished in this home. Okay? Any questions on any of this? Seeing lots of yawning and bending over. You guys are a little sleepy. No? You're doing great? But for the rest of you, I think it's time to go back to kindergarten. About this time in kindergarten, we would have nap time. Let's have some nap time. Serious. Put your head down on your desk, close your eyes. We'll play a little game here. You gotta play along now. No cheating. Head down, eyes closed. I'm going to ask you several questions. These are multiple choice questions. Your response will be by raising your hand. So I'll tell you what your options are, and then you can raise your hand. My first question is, what is the main color of the bulletin board in the back of the room? Your two choices are red or blue. All those that think the main color is red, raise your hand. If you think it's blue, raise your hand. Okay, next question. How many sinks are there in this room? Your choices are 1, 2, or 3. All those that think it's 1, 2, and 3. Okay? By the way, you never use those sinks unless I specifically tell you to. What color are the stripes on the chemical shower in the front of the room? You have two choices, green and white or green and yellow. You think it's green and white? Hands up. Green and yellow. Okay? Last question. This is a true or false question. Somewhere in this room there is a miniature stuffed dog. True? False? Okay. Put your heads up now. Let's look around. See if you were right. Bulletin board. Main color is red. I mean, and that's pretty obvious too, but here's why a lot of you get it wrong. You walk in and you see the desk with all the blue seats, and that kind of gets stuck in your head as the color, okay? So a bunch of you got that wrong. The next one was, how many sinks are there in the room? The answer is 3. 1, 2, 3. Those two we will use to get water from for different labs, but for the most part, you don't mess with them. You don't get drinks out of them. This one's always turned off. Next question. What color are the stripes on the chemical shower? They are green and yellow. I think only 1 or 2 of you thought they were green and white. Now, I just shown that to you, so hopefully you got that one right. Lastly, somewhere in this room there is a miniature stuffed dog. True or false?
True.
True. Okay. Little quick story about our mascot up here. This is our mascot. His name is Foo-Foo. Say hi, Foo-Foo.
Hi, Foo.
There you go. Foo-Foo was the only thing in this room when I moved in. It was kind of creepy. When I came in to take over, no, seriously, when I came in to take over, there was absolutely nothing in any of these shelves, cabinets, anywhere in the room. It's Foo-Foo. It was sitting right on that shelf. The teacher before me had taken everything. It was a little creepy. I walk in, there's this little miniature dog staring back at me. So I figured he had been here before me, he had the right to stay, so he's now our official mascot. Okay? So if you have any problems with this class, you take it up with Foo-Foo. Come over here, you can have a little discussion. Alright, any ideas on why I just did this? Trying to develop the skills of observation. You know, so much of the time you guys walk around and you're totally unaware of what's going on. Stepping on bugs, don't even know what species they are, right? Walking by people, you don't even see your friends sometimes. I could probably tape a live monkey on the ceiling with duct tape and you wouldn't even notice it. You'd walk right underneath. Right? Unless he pooped on your head, you wouldn't even notice it. And as a scientist, making good observations is an important thing. We have to be aware. You know, we're doing an experiment. We have to be aware of what's happening. So it starts by using our 5 senses, which are touch, smell, sight, taste, and hearing. Okay? Our 5 senses. Of course, the main one we use is sight. We're visual creatures. We use our sight a lot. And when at all possible, we want to use the other senses. I can make observations about this can. I can observe that it is made of metal, that it's smooth. I can smell it and smell a metallic scent. Okay? I can measure the height and the diameter and the circumference of the can. And that's really more what a scientist likes to do. They don't say the can is tall, because tall is compared to something else, right? What are we writing? Don't worry about that. You can write that. Okay? They don't say the can is tall, they measure. They get out a stick and they compare it to that stick. And they find it's 8.6 centimeters tall. They have a specific number. Okay? And we try to do that whenever possible. Now sometimes scientists cannot directly measure or observe. For instance, we want to learn how far it is from here to the sun. You think someone took a tape measure and ran it all the way to the sun? You might have wondered at some point, how do they know that? Well, they infer it. Okay, and inference is something that a scientist does when they can't use their senses to directly figure something out. So they try to figure it out by clues. For instance, if I want to know what's inside this can, but I can't open the can, well, I could shake it. Maybe I don't hear anything, but I know something's in there. There's a little hole in it. So I get a pin. I stick it in there and it goes, ow! Well, There's something alive in there. There's something that has a brain that reacts. Okay, that's a good clue. It's a miniature person, right? Or maybe I take the pin and I stick it in there and I hear pop, and air comes out. A balloon. Now, do I know for a fact that that's a balloon? No, it could be the little miniature person in there going pop and blowing air out. I don't know that. I don't know for a fact. I did not directly observe it. We call that an inference. You get the idea here? It's not something we use our senses for directly, but we got clues that led me to conclude that that's what's in there. So we're going to have to do both. But if ever possible, we want to be able to open the can. We want to be able to run the tape measure to get those observations. And we want to use a standard, a system of measurement like the metric system. Okay? I understand Mr. Franz covered some of the metric system with you today. Excellent. How many of you have had the metric system at some point before this year? You should have had it repeatedly. What I'm covering, put your hands down. What I'm covering in here is all just review for you guys. This stuff up here, I don't want you to do this now because we don't have much time, but at some point today or tomorrow, tomorrow or the next day, you want to get this down. This is some helpful information. It's kind of on this worksheet that I'm going to give you. But we need to learn how to use these prefixes and understand the metric system. Some of you have been really resistant. You kind of learned it, but then you forgot it. This is something that anyone that's in science should know forwards and backwards. And if you plan on living in another country or traveling to another country, it's also to your benefit to know the metric system. How many of you love fractions? Adding, subtracting, dividing, multiplying fractions. Okay? So we got some math people in here. Most of us don't like the extra work of adding, 7/16 to 5/32. We would much rather deal with the metric system where you don't have to have fractions. Okay? I'm going to get a t-shirt made up that says fractions suck. Because that's basically my feeling about fractions. I don't want to deal with them if I don't have to. So if I haven't convinced you yet, hopefully eventually you'll believe that learning the metric system is going to make your life easier. Okay, if I can get a volunteer to read that first paragraph aloud. Thank you, Brianna.
Measuring is an important skill. Measurements tell how far, how large, and how much. However, in order for a measurement to be useful, a measurement standard must be used. A standard is an exact quantity that people agree to use for comparison. When you measure, you compare a known amount of a standard to an unknown amount. Everyone uses the same standards to measure objects, when the measurements can be compared to each other.
So a standard, it's just something that you decide, this is what we're going to compare everything to. This is a standard. This is called a, no, not a yardstick, a meter stick. And we all agree that we're going to use this to measure. Next paragraph. Volunteer? Thank you.
In the past, people used related objects and body parts as standards. The width of the thumb might have been an inch, or the length of the king's foot might have been called a foot. A person's stride might have been a yard, or a horse might have been 15 hands tall. Since these measurements were taken using standards that vary from person to person or from the king, the measurements of the same object may have been totally different. Each village, state, or country had different standards, so that each had a different measurement for the same object.
So picture this. We're coming up with a standard. We have to decide what we're going to use as our measurement. They take the king's foot, for instance, and they measure it. And they make a little stick, the same length as the king's foot. And they say, this shall be a foot. Now, meanwhile, in France, the King of England did this, but in France, they do the same thing. So the French king has tiny little feet. So when the French try to trade things with the English, and they order 3 feet of carpet or whatever it may be, are they going to get a better deal or a worse deal? Better deal. Because they're expecting 3 feet like this, but in England, 3 feet are much bigger. So they're going to get a lot more. And when the British trade with the French, they're going to get a lot less. Okay? Everyone has to have the same standard and has to agree on it. So that's what led us to the metric system. Okay? We all have one system that everyone uses that never changes. Okay, what happens when the king dies and another king comes around? Do we have to make a whole new set of measuring sticks? That would be kind of silly. So we want to have a system that sticks around and is the same everywhere, the metric system. Next paragraph. Any volunteers? Thank you.
In 1800, scientists developed a measurement system in which the same measurement standards were used worldwide. By using the system, people everywhere would get the same answer when they measured the same object. All scientists and most countries in the world agreed to use this one system of measurement. In 1960, some improved version of metric system was provided. It is known as an international system and is usually abbreviated SI. SI is now the standard system of measurement used worldwide. All SI standards are universally accepted and understood by scientists.
And that last sentence is not entirely true. I'll give you an example. But you might be wondering, why is it called the SI system and not the IS system? Because not everyone speaks English. And the system was originally developed, I believe, in France, and it was called System International or something like that. And that's how it got its name, SI. So can you see the benefit of everyone having the same system? Particularly if you're a scientist, but just for the regular person. If you have a pen pal in France and they send you some recipe, it's going to have measurements like deciliters and centiliters. And you're going to have no clue. Your measuring cups aren't anything like that. You send one back to them and it says add 3 cups of flour, they're not going to know what you need. It's going to make it very hard to communicate. So in general, scientists agreed that they were going to use the metric system. In fact, all major developed countries agreed to use the metric system. Only one is really not doing it, and that would be us. It's kind of an embarrassment. We're supposed to be ahead of the times and all of these things, and we're really behind. You go to Europe, and almost everything is going to be in the metric system. Makes it really confusing for Americans when they travel. Can you put that away, please? So, if you want to communicate with others, particularly scientists, you should all use a metric system. We have problems even within our country. They told me, by the way, back in the 70s, that all of us were going to be switching to the metric system and that there would be no more gallons and quarts and pints and miles and all of these things, inches and feet, that they were going to be gone within a few years. Well, here we are in 2007 and they're still around. Every other country has pretty much gotten rid of them. We now know about 2-liter bottles. We've seen some signs on the highway that say kilometers per hour, but we really haven't changed. And more recently, there were 2 groups of scientists working in the United States on a probe that went to Mars. One group was supposed to do all the calculations for how that probe was going to fly and orbit Mars. The other group was supposed to put it into the computer to make it actually do it. One group was using the English system, one was using the metric system. That's what the probe did. It went crashing right into Mars. Okay? Instead of orbiting, it went crashing in. Hundreds of millions of dollars and like 4 years of flight time went into this probe, and it went crashing into the surface of Mars. I'm sure some people lost their job over it. Thank goodness there were no passengers on that spacecraft, because they would have lost their life, just because we're not using the same system. Now, we don't just measure length in the metric system. This is the base unit for the metric system in length, okay? And this is called a meter. We measure mass in grams. You see this in the table there just below. Is a gram a big amount? No, it's a pretty small amount, just as far as you think, about 2 paper clips worth. Okay, you guys think of mass as weight. It's really not the same thing, but they are kind of related. We'll get to that later. So we're going to be measuring grams as well as meters, and then we're also going to be measuring liters. Liters is a measurement of volume. Volume is not how loud something is. Volume is about how much space something takes up. So below my hand, this is 1 liter worth of liquid. It takes up 1 liter of space. I don't care about the color. I don't care about the substance itself or its weight. I only care about the amount of space that it takes up. So whether we're doing liters, grams, or meters, we still use the metric system. We even use it for temperature. In the metric system, it is degrees Celsius. Whereas here, we're like one of the only countries that use degrees Fahrenheit. Makes it very confusing again when you go overseas. You don't even know hot or cold unless someone tells you, right? So sometimes this measuring stick is perfect. It's appropriate. You can flip to the next page. Sometimes it's way too big, and sometimes it's way too small. Give me an example of where this measuring stick would be way too big for a measurement. Yeah, let's say that you want to measure the thickness of that pencil lead. You're going to do it in meters? 1. It's one of those. No, it's not 1. That'd be a pretty thick pencil, right? It's far less than 1. It's like 0.001 or something like that. Far too small for me to measure with this long stick. So in that case, I'm going to have to take this measuring stick and chop it into smaller pieces. I could chop it into 10 pieces. How big would each piece be? Imagine, you chop this into 10 pieces. How big would each piece be? Show me with your hands. What do you think? See this? Okay? It's going to be about the width of your hand. About that big. Okay? Each piece. I could chop it into 100 pieces. How big would each piece be? Show me. It would be about the thickness of your pinky. About that big. If I chop it into 1,000 pieces, how big would each piece be? We call that a millimeter. So what we're doing with the metric system, and again, I'm assuming you guys have never covered this before, when I know you have, is we're taking this thing called the base unit, meters. And if it's okay to use, fine. This would be a good thing to use if I'm measuring this table, 2.5, okay? That's a nice, easy number to work with. But it wouldn't be the right thing to use for the pencil lead. The number would be way too small, with too many zeros there. Would millimeters, this length, be a good way to measure the distance from here to Phoenix? No, it would be a number that would be way too big or small. The number would be big. There's a lot of these between here and Phoenix. See what I'm saying? So we wouldn't want to use millimeters. All we're doing when we use these prefixes is we're saying it's that broken into smaller pieces. When I say deci, when I put deci in front of something, that means 1/10 or 0.1. It's not the full thing, it's only a tenth. A tenth of the entire thing. Okay? That's how big a decimeter is, about the width of your hand. Centa is 0.01. 100. It takes 100 of those to make one of these. And milla is that big. If you can visualize these guys, it really helps to understand and remember the system because you start to use it. So that's why I teach the metric dance. You ready to learn the metric dance? Okay, you gotta play along. You gotta be stupid sometime here. I'm plenty stupid up here, so you guys can be stupid as well. Okay, here's the metric dance. Follow along. Meter, decimeter, centimeter, millimeter, millimeter, centimeter, decimeter, meter. We'll try that again. Millimeter, centimeter, decimeter, meter, meter, decimeter, centimeter, millimeter, centimeter, millimeter, 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 decimeter, decimeter, meter. Okay? You'd be surprised. You guys laugh at me, but I see people on the test. They're reading the question, they're going like, and they're doing the metric dance. Because they forget how big, you know, if I say it's 10 decimeters tall, how big do you think that is? Show me. 10 decimeters tall. Same as a meter. If I say it's 100 centimeters tall, how big is that? A meter. If I say it's 10 millimeters, How big is that? Excellent. Come on up here.
Yeah.
No? What? Not you. Sorry. Gold star. Hang on to that. It goes towards a gold star. Put it in your notebook somewhere. Good. Usually I don't get the right answer on that question. So 10 millimeters equals 1 centimeter. 10 centimeters equals a decimeter. 10 decimeters equals a meter. 10 meters equals, no, 10. Decameter. This room is about a decameter wide. Okay? 100 meters equals hectometer. From here to the fence way back there that they're working on would be about 100 meters. Okay? You can refer to it as a hectometer. And a kilometer is about the distance from here to Saguaro. So when I use these things, I could throw those prefixes on the front of anything. And I'm encouraging you to do this now. Okay? When you go to lunch, if you're really not that hungry, if you really don't want, a full cookie, because the cookie's just a really big one, you just want a tenth of that cookie. Don't order a cookie, order a tenth of it. Dessa cookie. A dessa cookie would be 1/10 of that cookie. Okay? A centa cookie would be 100th of the cookie. That's just like a few crumbs. Okay? Or if you're really hungry, instead of ordering a pizza, order a deca pizza. That would be 10 pizzas. Get it? That's all they are. The prefixes just change how many of these. This makes it more. This makes it less than 1. You're going to have this memorized at one point and know the prefixes. And this little King Henry died Monday drinking chocolate milk thing is a great way. I'll go through this some more with you tomorrow. We're on to the back when we talk about making these bigger and smaller. And you see that table there. Okay? Let me point out a few things before we go so that you don't make mistakes on your homework. 1 through 5 there. What kind of sentences am I looking for? Complete sentences. Obviously, number 1 and 2, you're finishing the sentence, so make sure you put a period at the end. Then, look at the next page. And you can see the first section, it says, match the prefix with its number. I don't want fractions. I hate fractions. What number goes with Miller? 0.001, and you see it here on the other side, 0.001. It's 1,000th of whatever it is. So you can go ahead and write that in. 1,000 stands for what prefix? Kilo. So you write in K-I-L-O. Eventually you're going to have all these memorized, and you won't have to keep flipping back to this page to see that. Okay, everyone understand how to do the first section? The next section, you can see an example has been done for you. 0.01 meters. All you have to do is write it in the whole word with the prefix and the base. 0.01 is centa. And since it says meters, we write centimeter. But look at the next one down. 0.1 liter. 0.1 is what prefix? Deci. So you write D-E-C-I, make sure you spell it right. And then what? Liter. So you just put the two together. In the next section, you're doing just the opposite. I've given you the word, and now you're breaking it into its prefix number and the base. So for kilograms, you would write 1,000 grams. Exactly. And you'd have both pieces. Okay, in the next section, it says HG, the correct abbreviation or units. H is short for hecto, so you write out hecto. G is short for grams, not meters now, but grams, so you write hectograms there. The next one, you have to do just the opposite, okay? All right, and don't forget to circle the one that's larger in the last section. This will be due tomorrow. See ya.